think I just started. For the midterm review, and as you know, the format of the midterm is everything like the question on the gradients. So I'm going to review the most of the questions on the gradients, and some of yours post a couple questions on the piazza, and I'm just go over from begin with those questions. So the top one is from gradient quiz 3, I think. Yeah, quiz 3, and there's two questions about the precisions, and some of you are confused about the weights updating, right? Anybody? So so for simple precision, it's like yeah. So I think Professor already described it very clearly. So this is oil include, and for this question, so this is the question on the gradient 3, and we have two training inputs for the WXYZ. The first one is -1, -1, 1, 1. So as you can see, we multiply the input and the weights and sum up all of them in this node, and we compare with the threshold to see the output. If this is above the thresholds, this output will be 1. And also we come with a true label. We call it ground truth. It's the ground truth is -1. So we multiply over here. There's so this one will be 0.4. It is over the the threshold, so the output will be 1. But as you can see, the ground truth is -1. So which means we made a mistake. So how we update the weights is, so this is the true label, and our predict is 1. So the difference is -1 minus 1 will be -2. So we have that output error will be -2. So we update the lambda. The lambda is -0.1. So we add, for this one, we add -0.1 multiply -2 multiply -1. So this one is the lambda. It's lambda. This is the arrow. Can you see that? And this one is the input. The original input is here. It's -1. So this equals to 0.2, and that's the amount we have to update to the old weight. So the new weight of W will become to 0.3. Clear? You have a question? Yes, so this is how so the W is the same, so plus 0.2 equals to 0.4. And this is the 1, so 1 will be like 0.1 multiplied -2 multiplied 1 will be -0.2. So this one will be 0.1, 0.2. That's how we update the weight. So you have any questions?
Yeah.
Yes.
What is GT?
Ground truth.
How did you find out that?
It's coming with the training example. So as what you can see in your project, so every column has a lot of variables. We might be 0, 1, 1, 0, 1, and the last one usually is the ground truth, and this will denote and will tell you it is 1 or 0 or any other labels. So when we training any algorithm, so this is your input here. This is your input, and we take this out at the first time. We learn the algorithm, and we predict our label like 0 or 1, and we compare with the two labels. That's how we like correct our directions. Yes. Any question? Okay, so there's another question similar to this one. So the update method is the same, but this question is change the lambda to 0.1, 0.01. And also there's a rule that W equals to X equals to -1, and Y equals to Z equals to 1. Well, basically it's almost the same, so I just skip that question. The two question is the same. And the third one, the simple neural network is just same as what you did in the project. So if you're okay with your project, you should know how to do that question. And so there's some other algorithms. Do you guys want me to go through the candidate elimination, or window, or find as anything? Okay, so I don't know. Yes.
Could you go through the candidate elimination algorithm about that sunny warm example?
Okay, yes, no problem.
I don't understand how to find out the number of hypotheses in the vector space.
Okay. So, candidates. So at the first beginning, we have S1 and G1. And S1 will be S0, sorry. So because there's no input coming in, so there's one, two, three, four, five, six. So this is the initial hypothesis. And now we have a new input for Sunny, warm, normal, strong. So, and also we know this is a positive sample, which means the true label is 1 or yes. So when we coming a yes sample, we update the S1 and the S set. So there's nothing over here, so we just put everything into S1. S, W, and S, W, S. So this is the first step. And also this will be G1 too, because we didn't update it. So the second one will be around here. So S, sunny, warm, high. Strong, warm, thin. Strong, warm, thin. And this one is also a yes label. So we continue to update the S. And we compare with the S1, the previous one, and the new the new input. So we find out this one doesn't match. So we generalize this one. As a question mark. And G2 is step 2. And the new one is no. And there's a raining cold high, strong warm change, strong So when a negative sample coming in, we have to update the G. So now G2 is different. The G3 is different. G3 will be sunny, warm, and sad. So, so that's because we see this is the negative sample, and this one compared to here, this one match, and this one we don't clear. And so this one is matched, and one matched, and the question mark we skip that, and this one doesn't match because for the positive one we have yes, the S, and the negative one we also have a yes. So this one is same as this one, which is not cool for us. So we skip that. Same as here, same as the warm, and this one we match. So we have a same here. So that's how we update that G. And the S3, same as here. Yes?
Could you tell me how we are matching once again?
Okay, so suppose this is the target set we are looking for. So this is for the true labels, I mean the positive
Yes.
labels. So we can change it, like, we can take a reverse for this one. So there will be S, W, N, strong, what's the other? Weak, warm, cold, and change. Yeah, so here. So you compare with this one as this one. Yes.
But we have third value for the first attribute, which is cloudy. Do we consider that also?
Yeah, just if, that's why, I just take an example, because
Okay.
just if this doesn't match, and we cool that. Yes.
Negative example does not affect the this, right?
The S? No,
Any
negative affect the G1.
It does not update the hypothesis.
What do you mean? We update it.
It should, I think that is what was said. The negative examples do not update the hypothesis. Only the positives, it's bitwise done, and then whatever is like and, we take it.
It's like we are going to strip the whole space smaller and smaller. So this is the most specialist one, and this is the most generalist one. And we are getting, what we're trying to do is, if this one match this one, then we get a target. Yes, that's what we do. Okay, so you understand how we come in with this one? So we have another. Yes. SW high. strong, cold change. Okay, now we have to update the S4. So now S4 will be sunny, warm, and strong. Because this two doesn't match. But also we have to delete some of the elements from the G3 because it doesn't match. So this one, gone. So G4 will be S. W. Any question? So this is the hypothesis after the 4 training sample. This is what we get.
So, which ones do we calculate, like which ones do we count for the number of hypotheses in the vector space? All of them?
So I can take an example. So suppose this is what we learned from the training data set, and now we are coming to a new one. Oh no, the new one. So the hypothesis will be like so. If we have these two, we can also have another 3. Sunny, strong, sorry. And sunny, warm, and warm and strong. So 1, 2, 3, 4, 5, 6 will be all the hypothesis classifiers. So now suppose we have a yes.
The sixth one is the same as the second one.
Which
Oh,
one?
never mind. I'm wrong.
Okay.
Uh,
Suppose we have sunny, warm, normal. Sunny, warm, normal. Strong, cool, change. Strong, cool, change. So, how many hypotheses is positive? Anyone can tell me? So we can compare one by one. So sunny, warm, whatever, strong. So this one, check. And sunny, whatever, check. Warm, whatever, check. Sunny, whatever, strong, check. Sunny, warm, whatever, check. Warm, warm, strong, check. So all check. So it has to be a positive. But some of the input might also agree with part of them. So there will be we don't know. Okay, so this is the candidate image, and so you have any question about it and others? I mean, because if you know this question, the font as is quite easy. It's just the upper part of this question, this algorithm. So just ignore what we did on the G part. And so you have any questions? So do you want me to go over the window? So I'm not go over the algorithm again, so you can find out in the slides of professors. So suppose we have a new income input, sorry. So suppose we have 6 x1 to x6. The first one is 1, 0, 0, 0. So as usually we just for every promotion or any others just get a double. So and the threshold will be half. Okay, so let me do this. So the lambda will be 2, and but now I set up the threshold as 6. So the first one will be, and all the weights, initial weights will be all ones. So W equals 1 equals W2 equals everybody. W6 equals to 1 at the first beginning. So we can see it's 1, 0, 0, 0. And we predict as a 0, which is correct. So we don't update anything. And the second one will be and this one is a 1. So now we can calculate this 4, and 4 is lower than 6. Okay, let me put the input over here and the weights over here, okay? So this is the first step, and the second step, we calculate over here is only 5. So the output will be 4, and the 4 is lower than 6, so we predict as 0. But it is wrong. So we have to do take the weights to half. No, we do the promotion, sorry. We do the promotion, so this one will be 2. And 2, 2, 2. You have question so far? And this one is 0. So this one's 0, so the output will be 2, still lower than 6, the threshold. So we put input will be 0, and which is correct. We didn't update. And the new input will be 0, 0, 0, 1, 1, 1 as a negative. But over here we can see this is 1, 1, 1 multiplied 2 will be 6. So it's same or above as the threshold. So we predict as 1, but it is wrong. So we have to take all the ones weight to half. Yeah, this is what we do. This is what we know. It's quite easy. Just but usually the threshold we take as half of the numbers of the, like over here it should be 3. Just usually. So you have any other question about the gradients? Like you
In
don't.
this case, threshold is 3, right?
I set up as 6.
Oh, okay.
Yes, but usually we set as 3.
I don't get how the last one is, how you divide it by 2.
So here, the weight is here. So you multiply them with this. So will be 0, 0 plus 0 plus 0 plus 2 plus 2 plus 2 equals 2, 6. Right? So it's equals or greater than the threshold. So we predict as 1, which is wrong. And I saw some of the questions on Piazza is about the quiz 5, the MLE. Excuse me. There's a distribution A and distribution B, and we can see ones, zeros, ones, twos, and threes in there. So there's P1, P0, P1, P2, and P3, which is so this question is really easy. So if you want to know the MLE for this one, just So how many times we see the, suppose we have the A, B, C, D over here. Means how many times we see the zeros and or ones or twos or threes. Just take the P zeros to A, multiply P1 to B. That's how we calculate our value. That's it.
Can you discuss the question on quiz 4, the map and the MAB problem we had?
Quiz 4.
Yeah.
Which one?
With the map and MAB quiz.
So the number hypothesis or the doctor, the medical,
No, not the doctor medical. That's
Okay.
the base theorem.
okay.
The other one.
So this one is just so we have H1, H2, H3, H4. So first of all, the likelihood will be 1 will be like this. So I think professor has a very clear handout, and I will find it for you. But all of this question is just about the Bayes rules. So if you don't understand it, just go back to check the Bayes rule. So I can't find it, so you just come back after the course, I will find it for you, okay? So that question is just go over the base rules. There's an equation on the slides, just follow that. And same as the medical question too. So I think that's it. Yeah, if you have any question, just pop up. And good luck with your midterm.
I have a question. First one, how did you get the arrow calculated by -1 is equals to?
So this is the true label
Okay.
and minus to the one you predict.
So the choose label is
true
always
label is minus one.
okay.
If
Is
you
it always
predict
minus
one. No, just it's coming with the input.
Okay.
So the input will tell you what is the input and also the ground truth of this input.
Okay.
So you use the ground truth minus to the one you predict.
Okay.
So if we predict correct, right? So this one will be minus one. So will be minus one minus one will be zero, which just same as the common sense. Your hero of the predict is zero means you didn't make any zero. Error.
Zero.
Yeah.
So is it always correct if the error is zero?
Yeah.
Okay. So for the third one, I don't understand like how did you determine like when when the condition is correct and you do a promotion and when it's wrong and you do it divide it by half?
So you multiply with your input and the weights one by one
Okay.
and sum them up. So you'll get a result, right?
Okay.
Compare with the result with the threshold you set up. Usually it's half of the numbers of the input. So here is 3, but I set up as 6 because it's more clear.
Okay.
Yeah, okay, so like this. The weight is over here and you multiply here, so 0, 0, 0, 2, 2, 2, right?
Right.
And sum them up will be 6. 6 is same or higher than the threshold, so we predict as 1.
Okay. So what if you choose the other value like says 5? So
Yeah, just compare with that. Just every time you do the after the multiply, just compare with the result with the threshold.
right.
Yes.
What about the step where you are doubling the value?
You can go back to see the window, like the algorithm, the code, the